Hello, we are back now with topic 4. And just to give you kind of an intro to this, we're going to be talking about polynomials kind of in their fractional form. So remember, another word for fraction is rational. And the topic of this whole unit, or the title of this whole unit, is rational functions. So we're going to start talking about what functions look like when there is, in fact, a denominator. Sorry, guys. Went somewhere else there. When there's a denominator in the function. So let's start first by talking about some definitions. So you'll notice that the title of 4.1 is inverse variation. So we say that an inverse variation is a relation between two variables such that as one increases, the other decreases proportionally. Okay, and we're going to talk about what that looks like in the sense of a function in just a minute. For the table to represent an inverse variation, the product of x and y must be constant. So constant means the same. And product, remember, is multiplication. So we're going to look at this table. When we multiply x and y, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 12, 12, and 12. Those are all the same. So when those products are all the same, we say, yes, this is inverse variation. Let's look at B. B says, does this represent inverse variation? Well, 1 times 20 is 20, but 2 times 17 is 34. So this is not inverse variation because these are different. Okay, so now let's look at how we represent inverse variation as an equation. So inverse variation is modeled by this equation where y equals k over x. In this case, k is just a number, and it can be any number, but it's called the constant of variation. Okay, so it can be 1, it can be 7, it can be 30, who knows? Like, it can be anything. The other way that I like to think of inverse variation, though, is this equation here, xy equals k, where k is that constant of variation. If you look up at example 1, our constant of variation here is 12 in that first example. So it's that k is the number that you get when you multiply your x and y values together. Okay, our next example is going to just show us how to use this. So example 2 says, in an inverse variation, x is 10 when y is 3. So if we know that xy equals k, our x is 10, our y is 3, so k has to be 30. And this is true no matter what x and y are. So then it says, write an equation to represent the inverse variation. So our equation is going to be xy equals 30. Or if you want to have that y by itself, it's going to be y equals 30 over x. And then we need to find the value when x equals 6, or negative 6. So when x equals negative 6, we're going to put in negative 6 for x. So that's our substitution right there, 30 and our negative 6. Y is going to be negative 5. Negative 5 times negative 6 gives us our constant variation of 30. So there's our equation, and there's our solution. Okay, example 3 is a nice little word problem. So it says, on the guitar, the string length, or S, varies inversely with the frequency. So what this means is we're going to have our SF equals K. And it says of its vibrations. Okay, so the frequency, so this is our F. F is 26. For an EG string is, oh, whoops, nope, that's our S. Sorry, guys. Wouldn't be a day with Miss Snow taking notes if I didn't get something wrong. 26 inch, that's our string length. So that is our S. And the frequency is that 32.9. So it says frequency is 329.63 cycles per second. What is the frequency when the string length is 13 inches? So this is a new S right here. So first of all, we have to solve for a constant of variation because we don't know what that is. So I'm going to plug in my string length for S and my frequency for F to find my K. And when I do that, I get that K is 8,570.38. You would obviously do that on your calculator. I can't say that enough. Calculator. Use them. Okay, so now we go back to our function, and our string length has been shortened to 13 inches. We don't know what our frequency is, but we do know that K is 8,570.38. So then what we're going to do is we're going to divide both sides by 13. And we get, using our calculator, that the frequency is 659.26. So that is our frequency. Okay, example 4 is talking about how we graph this function. This is a function where x is in the denominator, okay? And what you have to think about is that when x is in the denominator of any function cannot equal 0. So denominator, or the bottom, cannot equal 0, ever, okay? Because then we would be dividing by 0. So we know that our domain of this function, x, cannot equal 0, ever. So that means that this line, this vertical line, where x equals 0, is not part of our function, okay? This is called the reciprocal function. And it maps every x to its reciprocal. So if you think of x as 2, if x equals 2, then y is going to be 1/2, right? If x is 1, then y is 1. If x is 1/2, the reciprocal of 1/2 is 2. So we're up here. So then this function looks, oops, I wanted to change color. This function looks like this, okay? Now, what you will notice is that y is also never going to be 0. Because if x is 0, y is undefined. It goes crazy. So we also have a horizontal asymptote. They're called asymptotes, where the function can't touch at y equals 0. So our range is such that y, not x, y does not equal 0. Oh, I'll have to do it up here because it's getting ready to shut me off. So y does not equal 0. Okay, so we'll hold up there and we'll finish talking about this graph in the next